In this video, we're going to take a look at higher derivatives. Now, so far in A-Level Maths and A-Level Further Maths, we have only considered the first and second derivative for given functions. However, what we're going to do now in this video is consider the third and higher derivatives for given functions. And this is going to be particularly useful for our next video on the Maclaurin series. So truthfully, quite a nice, relaxing video really. Nothing too challenging and nothing in particular that is actually examinable, okay? But it is useful to go over this, so we're going to start here by discussing the notation. Now, if y equals f of x, then the first derivative of f of x is going to be given as, and this is something that you should be completely familiar with from A-level math, so nothing that you shouldn't be expecting here. So dy by dx is my first derivative then. So we get dy by dx. And this is equal then to f with a little dash, which we call f prime here. So we get f prime of x. This represents the first derivative then of f of x. So that's the first derivative. Let's make a note of that here. That's the first derivative then of f of x. So now what about the second derivative? So the second derivative of f of x is given as, so we get d squared y. We have d squared y over dx squared. Now for the second derivative, this is equal then to the derivative of the first derivative. Okay, so it's d by dx. So we get d by dx of dy by dx. And then in terms of this notation here, this would now be f with two little dashes, two primes. Okay, so it's f prime prime of x. So we get f prime prime of x there. Okay, and that represents the second derivative of f of x. So now we keep going here. So this is what we're interested in now, the third derivative here. So in that case then, the third derivative of f of x, and you might be able to guess this straight away then. So we get d cubed y. So we get, so let me just make a note here. So that's the second derivative. So now for the third derivative then, we get d cubed y over dx cubed. So as you might have guessed then, this is the derivative of the second derivative. Okay, so we just differentiate the second derivative again with respect to x. So we get d by dx. So d by dx then of the second derivative, so d squared y over dx squared. Like so. And then again, what you might also expect here is we get f with three dashes now. Okay, this is f prime prime of x. So three dashes here represents the third derivative then of f of x. So can we generalize this? Well, of course. So the nth derivative of f of x, this is going to be given us then. So what do we get here? Well, I get d to the power of n, because this is the nth derivative. So we get d to the power of n y over dx to the power of n. So this represents the nth derivative then. So this here is going to be equal. Now, in terms of this notation here, the way that we represent this is f. And now we write this almost as a power. We've got f here with this little bracket of n of x. So this represents the nth derivative of f of x. Okay, so for example, if I wanted the fifth derivative of f of x, that would be f with this little bracket here of a 5 and then x. Okay. Now it is important to stress that you do need the brackets here with the power. Okay. Just writing f with a little 5 here is not the same as f with the brackets around it. So just to stress that here, it's really important. Do put the brackets around the number that you want to represent for your derivative. Okay, so for the 10th derivative, it would be f with a little bracket here with a 10 inside and then x. Okay, that would be the 10th derivative of f of x. Okay, so that's everything that we need here then in terms of the notation. So that's everything that we need then for our introduction to higher derivatives. So what we're going to do now is just take a look at a couple of practice questions for higher derivatives. Starting off with question 1 then, where we have a nice straightforward question here just to get us started. Now we're given that f of x equals 2x to the power of 5, and we want to find the value of the third derivative when x equals 2. Now to begin with, how do we know we're looking for the third derivative here? Well, we have 3 dashes, so this represents the third derivative. Okay. Now to find the third derivative here, what I'm going to do is start by finding the first derivative, then find the second derivative, and then obviously from there we can easily find the third derivative. Okay. So let's just start by writing down the original function here. We have f of x equals 2x to the power of 5. Okay. Now for the first derivative then, that would be f prime of x, that's f with a little dash. And this should hopefully be nice and straightforward. In this case, I'm going to get 2 times 5, which is 10, and reduce the power by 1. So we get 10x here to the power of 4. Let's keep going then. So now for the second derivative here, this would be f prime prime, so that's 2 dashes then. So f prime prime of x, this is the second derivative of f of x. What do we get here? Well, we get 10 times 4, so that's going to be 40. And again, we reduce the power by 1. So we get 40x to the power of 3. Now, like I said, this should hopefully all be nice and straightforward. So we now arrive at the third derivative then. So we get f with 3 dashes, like so. This represents the third derivative then. So we're going to get 40 times 3, so that's going to be 120. And again, we reduce the power by 1. So we get 120x to the power of 2, or 120x squared, I should say. Now, finally, we want the value then of the third derivative when x equals 2. So therefore, when x equals 2, so when x equals 2, what do we get here? So the value of the third derivative when x equals 2, that's going to be 120 times 2 squared. So 120 times 2 squared, that's the same as 120 times 4. And in that case, then we get 480. Okay. And there we have it. So nice and straightforward. That gives us the solution there to question 1. Moving on to the very last question, then question 2, where we're given that y is equal to the natural logarithm of 1 plus x, and we want to show that the fourth derivative then is equal to minus 6 all over 1 plus x to the power of 4. So we've got another pretty straightforward example to work through here. Now the first thing that I'm going to do here is find the first derivative. Okay, so we need dy by dx to begin with. So dy by dx then. So this should hopefully be nice and straightforward. So just differentiate y here with respect to x. In that case then, the derivative of the inside of the bracket is 1. So we get 1 all over the actual bracket itself, which is 1 plus x. So we get 1 all over 1 plus x there. So that is dy by dx. We now need the second derivative here. So for the second derivative then, this is d squared y all over dx squared. Okay. So I'm now going to differentiate dy by dx here with respect to x. So to differentiate this here, we now need to use the chain rule. Okay. So using the chain rule here, we would write this as 1 plus x all to the power of minus 1. Okay. So now differentiate this here using the chain rule. And what we're going to get then is minus 1 all over 1 plus x. Don't forget we reduce the power by 1. This will be to the power of 2. Okay. So if I write it in exponent form like this, or in index notation, we're going to get minus 1 plus x all to the power of minus 2. And we do this because we now need the third derivative. Okay. So we need d cubed y all over dx cubed. Okay. So again, just using the chain rule here, what am I going to get then? Well, for d cubed y over dx cubed, I'm going to get 2 here as my numerator. That's going to be all over 1 plus x, and again, reduce the power by 1. So we do minus 2, minus 1, so that would be to the power of minus 3. But if we write it in this form here, this would be 2 all over 1 plus x to the power of 3. Okay. Again, if we write it in exponent form or using index notation here, we'd write this as 2 lots of 1 plus x to the power of minus 3. And we do this here because finally we need the fourth derivative here. Okay, so therefore, fourth derivative now. This will be equal then. So using the chain rule here, so I've got 2 times minus 3, so it'd be minus 6. We then times that by 1 here because the derivative of the inside of this bracket is 1. I get minus 6 as my numerator. That's going to be all over then. So again, we just reduce the power by 1 here. So 1 plus x, the power minus 3, reduce that power by 1. So the power would now be minus 4. But if we write it in this form here, then we get minus 6 all over 1 plus x to the power of 4. Okay. And notice this here is exactly what we want as given in the question. So as required and question complete. Okay. And there we have it. So that gives us the solution to the very last question, question 2. And that actually brings us to the end of this video on higher derivatives.